All right, welcome back. We're going to do some more candy chemistry. And we're going to do some very basic chemistry with reactions. And we're going to test some white substances that you can find in your kitchen. And we are also going to find some liquids in your kitchen. So if we were doing this in at high interest day together, then we would have used different equipment. We would have used this well plate, and we would put our solids in there, and we would have used this pipette that you see here, because that'll allow us to transfer liquids. But luckily, we have some stuff around our house, and I bet you do too, that would work really well for this experiment as well. So I'm going to use a really small muffin tin, because the muffin tin is very much like this well plate. I can put different substances in each and mix them by putting liquid in them, and they're kind of their own separate containers. If you don't have those, I think another thing that could work really well would be a lid, a plastic lid from a container. And if you had some darker colors, because all of our powders are white, so I think it might be easier if you used that. So those are just some ideas of things you could use. You could use lots of plates or lots of cups. I mean, that would completely work as well. So just give some thought to what you might use. And if you aren't happy with what you brought with you, then just pause right here and go get what you need. Okay? I put this in the instructions, but you're going to need sugar, salt, baking soda, and you're going to need water, lemon juice, and vinegar. You probably want 1 spoon for each of the solids, so 1 spoon for sugar, 1 for salt, and 1 for baking soda, so you don't mix those. And then you probably want 3 different small containers, maybe small cups of water, lemon juice, and vinegar. And you don't need very much, so I would say 2 tablespoons at most is all that you would need for those liquids. This activity is in your book. So if you found the activity, it's called acids and bases. So the very first question on there talks about how acids and bases taste. So does anyone have any idea of how acids taste? What do acids taste like? There are lots of acids in our kitchen and things that we eat quite often. Some good examples of foods that have a lot of acids are things like our citrus fruits, so grapefruits, lemons, oranges. Those are all citrus fruits, and they have a couple acids, but one of the acids that they have is called citric acid. All right, so can you think about how some of those fruits taste? Particularly the lemon and the grapefruit. Yes, they taste sour. So if we're thinking about how acids taste, acids are going to taste sour. And so anything that would taste sour, there's a very good chance that there's an acid in there, and that's what's making it taste sour. Bases are something that we don't eat quite as much of, and so it's a little harder to find them in our kitchen, but we do actually have them. So bases are going to taste bitter instead. So bases taste bitter and acids taste sour. Okay. So what we're going to do is just do some fun reactions, and I'm not sure if you know my son Grant Nickel, but Grant is going to help me. So he's going to add some sugar to my 3 containers in the back here. So in my line here, I'm going to put, Grant's putting sugar and more sugar on the last one. Good. All right. And then in the next row, in here, here, and here, he's going to put some salt. He's doing a great job, don't you think? Yes, very All right, nice. And then the last thing that we're going to add in this row, in this closest row, is baking soda. So 3 things of baking soda. All right, good. Okay, so we have everything added. So we are ready to go. All right, now this will relate to candy. We just don't have any candy out yet, but that will come at the end. So the next thing we need to think about is how we're going to pull up liquid and where we're going to put that. Okay, so I think that this is probably something you've done around the house or at a restaurant maybe. You've had a straw and you use it to pick up liquid and then drop it back down. So you know that if you stick the straw in and then cover it up with your thumb or your finger and you pull the straw out, then there is some liquid there at the bottom, right? And if I let go with my finger that you can't see, all of that falls out, okay? So you can use a disposable straw or you could use a stainless steel straw. It doesn't matter, either would work, right? So whatever kind of straw you have. If you don't have that, you could just simply take one of your spoons and get liquid that way and pour it too. All right? So again, if you need to pause to go get more equipment, then make sure that you go do that. All right? All right, so pause if you need more. If not, we're going to keep going. All right, so what we're going to do now is the actual experiment. What we want to do is to keep track of what happens when we add these different liquids to these different cups. So remember that we've got sugar on the top, salt in the middle row, and then baking soda on the bottom. And in this first column, right, I'm going to put water. So I'm going to put water in the sugar, I'm going to put water in the salt, and water in the baking soda. All right, and we're going to watch as Grant does that. Okay, so he's going to take a little bit of the water and put it in the sugar. Now, did you see anything? I didn't see much happen. Grant, why don't you add just one more portion? Good. All right. Not very much exciting stuff happens, right? It looks like the sugar kind of disappears. Does it look like that to you? I think so. All right. What's happening is that the sugar is actually dissolving. So if you have sugar on your tongue, you would feel that same sort of thing happen. If you put sugar on your tongue, you sprinkle a little bit of sugar on your tongue. Right? Your tongue is wet, and a little bit of that would dissolve. So if you felt how grainy that sugar was on your tongue when you first put it on, and then you let it sit just a little bit, it would slowly dissolve and it would be a little less grainy. So you could try that. I think that that would be kind of a delightful experiment. Okay? All right, the next thing we're gonna do is salt. So Grant, are you ready to do that one? So Grant's gonna he's gonna take his straw, he's picking up his liquid, and he's gonna put it in the container with the salt. Good job. And I think it seems like 2 might be a nice amount for the amount of solid we have. Okay, so again, not much exciting is happening. Grant, are you seeing much exciting happen?
No.
No. Basically, it looks like everything's dissolving again. So you could also do that experiment that I talked about with your tongue, with salt on your tongue, but that would not be nearly as pleasant, would it? I don't want to do it. Do you want to do it, Grant?
No.
No. Okay. We'll skip that experiment. All right. The next thing is baking soda. So baking soda is a little more powdery. The other 2 are grainier. So let's see if that makes a difference. All right, Grant's going to take a little bit more water. He's going to stick it in that bottom one. And we're going to do 2 because it just doesn't seem like, kind of depends on how much you have in there. All right, we'll see if anything happens. Not much to note, was what I would say. What do you think, Grant? Not much?
Not much.
Not much. Okay, so we're done with the water column. Remember that our water column was the one that was on the far left, okay? Now we're gonna do our lemon juice in the middle. So Grant, do you have lemon juice?
I do.
Okay, so lemon juice is going to be a little bit more yellow in contrast to the colorless liquid that water is. Right? And we probably should have gotten more lemon juice. We'll see if we can have enough. Okay, so there's our lemon juice and our sugar. And here's our lemon juice and our salt. And lastly, we have lemon juice. Ooh, that is the first exciting thing we saw. What did you see? Did you see bubbles? Yeah. So we saw bubbles when we added lemon juice to baking soda. All right, so that's something you probably want to write down. There are some lines there that you can write down, or you can use the little circles to write down what happened, that bubbles formed, right? So bubbles formed. Now, lemon juice is sour, right? Yeah, it's an acid. And one of the things I didn't tell you is that baking soda is a base. So, and it's a special base. It's a base of sodium. It's called sodium bicarbonate. And because it has that bicarbonate, it actually produces carbon dioxide when it reacts with an acid. And so that's what we saw is the bubbling of that carbon dioxide. Carbon dioxide is the same thing that makes your soda bubble and fizz, right? So it's that carbon dioxide that's making it bubble. Okay, so let's think about vinegar for a second. Does anyone know how vinegar tastes? So if you're having a hard time thinking of how vinegar tastes, if you know how dill pickles taste, dill pickles are in a solution of vinegar and some dill, but that would give you an idea. All right, vinegar is also sour. So what do you think is going to happen? Do you think we'll see anything happen when we mix vinegar and the sugar? Will we see anything when we mix vinegar and the salt? Will we see anything when we mix vinegar and the baking soda? All right, well, let's find out. Grant, do you have your vinegar ready?
Yep.
Okay, he's going to add the vinegar and the sugar. Not much, huh? Not much is happening. Okay, let's try the salt, vinegar and salt. I would say similarly, not much is happening. All right, baking soda and vinegar. Oh, I see some fizzling. I think some of you actually know this reaction works because I think I have seen some of you at the science fair with maybe some volcanoes or some reactions like this. This reaction is so loud we can actually hear it. I can hear those carbon dioxide bubbles, right? Can you hear them?
Mm-hmm.
Great. All right. So we saw that when we added our acid, either our lemon juice and our vinegar, we added those to our baking soda that we saw bubbles. All right. So now we're going to design our next experiment. And what we need to do is we're going to get out one of the Sour Patch Kids. Whoops. We're going to get one of the Sour Patch Kids out. Now, when I ask kids what their favorite kind of candy is, a lot of those kids say, I like Sour Patch Kids. All right? Now, me personally, I really like chocolate, and I'm not such a big fan of these Sour Patch Kids, but I know a lot of kids who like them. So what we're going to do is we're going to put those in a muffin tin. And because this is Grant, he insisted that we actually use his, you know that Grant likes cats a lot, right? So he insisted that we use this cat muffin tin that he has so that he can make little muffins that are in the shape of a cat. All right, so we've got these Sour Patch Kids in there. Now, Sour Patch Kids are sour, so we know there's already an acid there. This is a different acid than what we saw. The acids that we worked with were liquids. They were acids dissolved in water. These, the sourness that you taste when you eat a Sour Patch Kid is just a powder on the surface. And so what we want to do is think about what we need to add to make this fizz. What do we need to add to make it fizz? So we know we have an acid on the outside of that. All right, so we need to add a base. Okay, so what we're going to do is we're going to take our water, not very much water at all right, and we're going to add to that some of our baking soda. Okay, so we're going to get it into solution. So you can kind of see what I have added. Okay, so it's okay if we don't get it all to dissolve. It's going to be a little bit cloudy. I think that'll make our experiment just a little bit better. Okay, so now I'm going to have Grant take that baking soda and put it on the Cabbage Patch Kid, and then we'll see if we see any reaction. It's going to go fast, but do you see the little bit of bubbles? All right, can you do the other one too? All right, so here's the orange one. We'll see if we see it there too. Oh, yep, those bubbles go fast, don't they? There they are. All right, so we took our the sour acid from our Sour Patch Kid, right? And we added to that some baking soda, our base. And when we did that, we got our carbon dioxide bubbles. All right, we have one more little thing to show you related to these acids and bases. So the next thing I have are these candies. These candies are harder to find, so I'm guessing you didn't probably get these ahead of time. But these candies are fizzy candies, all right? And there's a couple different ways to make fizzy candies fizz. But these fizzy candies have two ingredients that are going to make them fizz. They have a solid acid and they have a solid base. And so when you suck on the candies, they dissolve on your tongue and give off just a little bit of carbon dioxide. And that makes, when you eat them then, you're gonna feel just that tiny little tingle of those tiny little carbon dioxide bubbles on your tongue. All right? So we learned a couple things in this. Acids react with bases, and acids taste sour. We didn't really talk about which bases would taste bitter, but bases taste bitter. And we know that baking soda is basic, and we know that any candy that we eat that has a sour flavor to it it's because there's some acid there. All right? Next time you get some of that soda can candy, or you get a Warhead or a Sour Patch Kid, I hope that you think about the acid that makes it sour.